Hi, my name is Jinnai. I'm going to talk about generating diverse and high-quality text by minimum base risk decoding. So, first of all, let me introduce what minimum base risk decoding, or MBR. MBR is to maximize the quality of the text, which is described in this equation. Don't worry, I'm going to explain the intuition. So, assume you have a prompt, what's in picture, and given a picture. You have a P model, which you can think of like LLM or something, and then this model is gonna output sequence or text, and you can generate a lot of sequence like this. So there's one input and there can be multiple outputs. What MBR gonna do is that you compute the similarity between these samples using the utility function U. So we compute the distance or similarity here. And then MBR gonna select what's in the center according to this metric or similarity U as the output of the algorithm. Empirically, it is known that this way of selecting a sequence generates very high quality text, especially in machine translation. So this is what MBR is doing. However, the problem of MBR is that it generates a set of output with very low density or even identical. So here are some generation examples in machine translation and in question generation. You can see that the output is identical in machine translation domain, and even for question generation tasks, you see semantically, identical sequences. So this is the problem we have for MBR. So the research question is that how can we generate a set of diverse samples with MBR? So, first we're going to show an observation that MBR decoding is the Medoid identification problem, which I'm going to explain it. So, finding the most centered point with some kind of metric in the dataset is known as the Medoid identification problem. So let's say we have this dots data points in 2D domain. Medoid is which aligns in the center of these dataset. So this is synonymous to what MBR is doing, where we have utility function as the inverse of the distance function here. So if MBR decoding is the Medoid identification problem, there's actually something called K-Medoid identification problem, which is a task to find the K most centered points, which can cover the dataset, like this. So, yeah, we can simply extend the Medoid identification problem to K-Medoid identification problem, and use that for generating sequence in MBR decoding. So, the proposed method is K-Medoid minimum base risk decoding, or KMBR. The idea is, simply use K-Medoid identification algorithm and find K diverse outputs. To understand it in a formal mathematical way, this is the equation we're going to find, and we're going to have this kind of outputs. Alternatively, decoding, DMBR, which is much more simple idea. We just simply add diversity penalty term to the MBR objective, like this. So this term is the MBR objective, and this term is the diversity term. In the paper, we use this as the diversity term, which is normalized to the size of the MBR objective. So we find it uncomfortable. So we haven't actually tried any other diversity metrics, so it's going to be a future work here. Anyway, so both KMBR and DMBR outperforms the baselines. And DMBR, which is nicer because it can control the trade-off between quality and diversity. So we also have the generation example. You can see MBR basically generates identical sequences, whereas DMBR and KMBR has much more interesting diversities. We also apply this to text summarization and image captioning, and we observe that they outperform the baselines. So to conclude the talk, MBR decoding is solving the Medoid identification problem, and we extend it to K-Medoid problem so that it generates K diverse outputs. And we also conducted an experiment and showed that the proposed methods outperform the baselines. So that's the takeaway. MBR is the Medoid identification, and we exploit it by extending it to K-Medoid problem. That's all. Thank you very much.